Hi Monarchs, in this video we will be studying the division properties of exponents. So in these problems we're dividing because the fraction bar right here means divide. So it's x to the fifth divided by x to the third. To do this problem, if we write out the problem, it would be x to the fifth, so that's x times x times x times x times x over x to the third, x times x times x. Now, x divided by any number cancels, or in other words, any number divided by itself cancels. So x divided by x cancels, cancels, and cancels. So after that, we are left with simply x times x right here, which is x squared. Okay, compared to this problem here, x squared divided by x to the seventh, x squared would be x times x over 7 of them. So 2 of them cancel. We're left with a 1 on top, so we have 1 over x to the fifth. I see I only have 6 of them, so there should be 7 of them. So we're left with 1 over x to the fifth. But a faster way to do these problems, so there's 5 x's on top, there's 3 x's on bottom, so there's more on the top. After 3 of them cancel, 3 of the 5 will cancel, so we'll be left with 2 on top, x squared. For the second one, all of these 2 cancel with 2 of the 7, so we're left with 5 of them on the bottom, 1 over x to the fifth. So the question is, where are there more? Are there more on the top or the bottom? And then how much more? In this problem, I see that I have negative exponents. So a first step would be to circle the whole powers that are going to move. I'm not circling the 5 because the 5 does not move. So when these things switch places, we're going to have 5x to the 9th over 10 x to the 7th. Okay? Now, if I just look at these coefficients, 5 over 10 reduces to 1 over 2. So cancels, and there's a 2 on bottom. But for the x's in the exponents, I have 9 x's on top, 7 x's on bottom. So I really have 2 more x's on top. And I have my final answer. So 2 steps that we're doing to these problems. We're reducing the coefficients. That would be 5 divided by 10 reduces to this 2. 5 divided by 10 reduces that 2. And then canceling exponents. We have 9 on top, 7 on bottom, so it cancels, and we have 2 left on top. So in this problem, we are going to reduce the coefficients and cancel the exponents. Okay, so reducing the coefficients, that's 4 over 6. So 4 over 6 reduces to 2 over 3. So the final answer will have 2 over 3. Then, canceling the exponents, we're canceling 2 of the 3, so we're just left with x to the 1, or simply x. This is y to the 1, so that y cancels with 1 of the 4, and we're left with y to the 3 in the denominator. For the z's, we have 8 z's on top, 3 z's on bottom, so we have a total of 5 z's on top, z to the fifth on top. Again, the top wins, and how much does it win by? It wins by 5. And so we have our final answer right here. Same concept of canceling here, but with fraction exponents, it might be easier to think of as subtracting exponents. So it is 2/3 minus 1/6, getting a common denominator. 4/6 minus 1/6 is 3/6, which reduces to 1/2. So this is really, in since the top wins by 1/2. So it's x to the 1/2 is the final answer. It's not 1 over x to the 1/2 because the top wins. So in this problem, okay, so this m to the negative 1 moves to the numerator and becomes m to the 1. So in the numerator we have m to the 1, m to the 2/3, n to the 2 over n to the 3. Okay? So adding exponents, we have 1 plus 2/3, so that's 1 and 2/3, or 5/3. So we'll have m to the 5/3 in the numerator. For the n's, we have 2 n's on top, 3 n's on bottom, so the bottom wins by 1, or by n to the 1. So our final answer, m to the 5/3 over n. In this problem, we want to move any negative exponents, moving the whole powers. So when I rewrite the problem, I'll have 12 y to the 6th, y to the 1, over 4 x to the 5th, x to the 1, z to the 5th, z to the 3. So simplifying that problem, 12 divided by 4, 12/4 is 3 on top. Then we have 6, and we have a total of 7 y's on top. So y to the 7th on top. On the bottom we'll have x to the 6th, z to the 8th. In this problem, we have 5 to the 7th over 5 to the 3rd. So 7 5's on top, 3 5's on bottom. So we have a total of 4 5's on top. And 5 to the 4th on a calculator equals 625. In this problem, this is power of a quotient, meaning we can distribute this 2. So it's 3 to the 2 over 8 to the 2, which equals 9 over 64 as our final answer. So squaring fractions is easy. You just square the top and square the bottom. In this problem, if we distribute the exponent of 4 to all factors, we'll have 3 to the 4th, x to the 4th over y to the 4th. 3 to the 4th equals 81, so we have 81 x to the 4th over y to the 4th as our final answer. In this problem, if we distribute the negative 3 exponent, we'll have of 6 to the negative 3, n to the negative 6 over 3 to the negative 3, n to the negative 3. Every single factor is a negative, so everything's going to move. We're going to have 3 to the 3rd, n to the 3rd, over 6 to the 3rd, n to the 6th. Okay, so simplifying that, we have 3 to the 3rd over 6 to the 3rd, so that would be 27 over 216, which reduces to 1/8. So the coefficients just become an 8 on the bottom. For the n's, we have 3 n's on top, 6 n's on bottom, so the bottom wins, and it wins by 3. So we have n to the 3rd on bottom, so just a 1 placeholder on top. I will see you in class tomorrow.